example, so it's clear. A chatbot, for instance, is something that can tell you the weather right now. It's just a simple call to an API. It's just an answer to a simple question. Just getting the information from somewhere and showing it to you directly. You can have also an automatic workflow, which is it could be like a string of actions, like sending an email. And then you have an agent. An agent, for instance, can analyze the weather, book a flight, send you a confirmation, but not always in the same way. The agent will have to reason about the environment, and you will have to act in the real world using tools and then decide what's next and what it's going to do. Why are we, not only we, everyone is talking about agents and implementing agents right now? Because the timing is perfect. We have now reliable models, we have more mature tools, and we have the infrastructure available to take these things to production. There are many frameworks for building agents. Of course, you can code them from zero, just doing all the logic and all the prompting needed for this. And but there are frameworks or libraries that makes this easier. Um, in this demonstration, we are going to be using Strands. Strands is a tool that talks very well with AWS, and it's simple to build agents with just a few lines of codes. I will share at the end, or if you can message me and we can share a documentation with details of how to use Strands. Then we will also use MCP. And what is MCP? MCP is a Model Context Protocol, which is a protocol that is solving a problem. We have different agents and we have different systems, and the way to access those systems is not always the same. So we will have to standardize this. That's when we use MCP. Everyone uses this analogy. There is like an USB-C for agents. What that really means is that it's the same way of connecting to any kind of tools without having to reprogram from zero all the different steps or things that your agent has to do to reach certain information. The idea is that it is a standard for agents that you have only one protocol that is useful for multiple systems. So when you use it, when you need to connect several systems or reuse tools. Okay, you have an agent. You build an agent that works perfectly on your laptop, but then you have to take it to production. What happens if 100 analysts are going to use the agent at the same time? You will need security, you will need scalability, you will need observability and governance. So this is where production platforms solve these gaps. For this, we have Amazon Bedrock Agent Core, which is an answer to all these gaps that we just mentioned. It has many components. The most important are runtime, where your agent runs. You have a gateway that handles the connection to all other tools. You have identity for authorization, memory for managing context, and observability for monitoring. The good thing is about this that also has some tools that you can use and are ready to use, like browser and code interpreter. This means that your agent can create code on the fly and also can browse the internet if you need, for instance, access to other systems that don't have an API. So inside Agent Core, using this tool, you can enter a tool, you can log in, and you can do things and have an output as if you had an API without building it. And these are the essential components to take an agent to production. Uh, you have these components at play. Everything with secure authentication and automatic observability. Basically, this runtime, which is the most important part, lets you run your agent on a serverless way that is super scalable because you have your agent built, you can build it locally, you take it to a container, and that container is run for all your users. Another important part is the gateway. The gateway can transform APIs that you already have into MCP tools. So you don't have to program your MCP server starting from zero. You just take an existing API, put it into the gateway, and the other way you are going to have the MCP connection. Well, I will show you in a quick demo two things. First, how to build an agent locally, then how to take it to production with Agent Core. Also, we'll show something about the MCP servers, how to build them and how to build them using Agent Core. And at the end, I will going to show a specific case of an agent that uses multiple agents to fulfill a request or a specific goal. Okay, let me show you here. We'll start with this demo. This is a mock agent, something, okay, let's imagine a startup that uses information from an external API. In this case, in this example, it's the NASA API, bringing information from Mars, the weather information, and also some pictures. And I will show you how easy it is to build an agent to get this information when a user asks some questions in natural language. Okay, first, of course, you have to set up your environment. You have to install all the libraries that are needed. You need an API key to, in this example, for the NASA API, but in your specific case, for the tools that you want to access, and you have to make them available to your agent. Once you define your environment and install all that you need to install, what you do is set up this agent. This agent is going to need tools. As I told you at the beginning, we're going to be using this framework called Strands, where using Python, you define with this decorator, you just functions that you put there inside and define as tools. And you specify what is the use of that specific tools. For instance, in this function, for getting the Mars weather, you specify here in natural language what this tool does. So when you ask something to the agent is going to look in the array of tools it has available, which one is the proper tool for the thing that you want it to do. This is the tool for getting the weather information. There's another one for getting the pictures. Once you have them defined, you define the agent itself. For this, you specify a specific model that is going to use. Strands, when you use it locally, it takes the credentials that you have defined with AWS, so you don't have to put anything here. It's going to realize, okay, this user is already a AWS user and it has all the credentials configured. So it connects to Bedrock. If you want, you can specify a model. If you don't specify a model, it's going to take one by default. Right now, the one that is going to be working by default is Claude Sonnet 4, but otherwise you can put here like I did, Claude 3.7 Sonnet. You pass that model and you tell the agent what you want it to do. This prompt can be anything where you specify the goal that this agent has. And this is an important part when you tell the agent, these are the tools that you have available. In this case, this for getting the weather data and for getting the pictures. Once you have this agent defined, you can start asking specific questions. So for instance, you send this query here, and for that query, it's going to determine which specific tool is the one that it needs to use and sends you the result. For this query, the right tool to use was the weather data, and here you have the data, and the same happened with the pictures. Okay, this is just a connection one-to-one with the API, but you can use these MCP servers to get an easier access to more tools. There are two ways, there are many ways to do this, but there's like a manual way of creating an MCP server. For instance, here I have coded a server where you basically you take all the endpoints that you have for this API and you make them available on a format that is compliant with this protocol. You run this as a server and then you can connect to it so the LLM has access to all this information. Here I am running this server. The agent can connect to it, and if you ask a specific question, it's going to get the answer through it. Okay, retrieving the information there, and the same way it's going to determine which tools it's going to use. This is all normal or local in my computer, but what happens if you want to make this available for more users and not just someone that is working here at my desk? This is where you use Agent Core. When you convert this local agent to Agent Core, the code remains more or less the same. You just add a few lines of code when you bring up this platform, which will create in your AWS account an instance of this container that I mentioned before and makes you available in the runtime of Agent Core. Also, what you can do is the creation of the gateway. Using the gateway, you just make available the API, and with that, have it converted to an MCP, which it shows here. Okay, so and you can run the complete solution, and instead of accessing the information in my computer locally, it's going to be connected to this remote server. This is one thing that I wanted to show you how easy it is to deploy this. There are many more things that you can do with agents. That's why I've brought another demo where you use not only one agent, but more than one. For instance, the problem that we are trying to solve here is for a sales team that needs information about contacts that wants to reach out to. How do you get that information? For that, a person that wants to do this manually, what it's going to do is, okay, I have, sorry, a list of companies. I know where these companies are. That's all the information I have. But I also have access to tools to investigate these companies. So I can search on the web to see what the web page of this company is. I can see what's the LinkedIn page of this company. what people is working in that company, what are the roles for that people, and depending on what I'm trying to sell or to message this company about is the contact that I need to reach. Do I need to talk to the CTO or do I need to talk to the finance people? That's something that we can define here, and we will also need some tools to get the information that I want. If I want browsing and getting the web page and all that information, I will need a browsing tool. If I want to see what's happening on LinkedIn, I will need some LinkedIn tool. If I want the phone number or the email, I will need a tool that is able to get that information with the information that I have. So I defined this agent that has access to all of that. I defined this agent in a way with a simple architecture that has one agent that is going to be coordinating all these things that I mentioned, and specific agents that have access to searching the web or searching LinkedIn or searching for the phone number. Why am I doing it this way? Because you can use one of the best and most expensive models to do all of this. But this is going to be very expensive because there's a lot of information that it has to be exchanged to get all this information. But there are some of these tasks that do not need all that power, all that intelligence. You can use a smaller model that is going to be cheaper to do things very specific, like uh, with LinkedIn URL searching for an email address or searching for a phone. You don't need a super intelligent model to do that. You can use just a small model to realize, okay, I have this information, then I call this tool and get this result. This is how this is built. A very important thing here is, apart from getting access to the different tools, which are defined here, each in their own file, is having the right instructions of what you want the agent to do, and you need to have observability. You need to see what's happening. You need to see how much this is going to cost too. Let me try a specific example. I'm going to create an input file here. You can use this one, where I'm going to ask this agent to search for these companies which are located in these countries. In the prompting, I specified that not that I want a CEO or CTO or something special. Yeah, I put in the prompt that I want to sell a specific cloud solution. So the agent needs to be able to find me the relevant contact within that company. So if we run this, I can specify, okay, you can enter the companies one by one in this example, in this demo, or you can input a CSV. If you select the option 2, it's going to take this input CSV and it's going to populate another CSV with all the information that we need. Okay, here I have different options. Uh, this is the complete agent is the one of that I mentioned before, is and one agent that does all of this. Uh, this is one of the most intelligent and most expensive agents. You should use this option if you need like a very exhaustive investigation of this company. Otherwise, you have this other optimized agent, which still uses this other model for everything, but it doesn't use all the information. It limits the context of what it's sending. If it makes a search and it gets, I don't know, 100 results, it only works with the first 25. So this limits the amount of tokens that you use, and it's going to be a little bit cheaper. And the most efficient uh, alternative is number one, which is the one that is using multiple agents, which is what we really recommend to use in a real use case where you don't need to spend that much with a better and bigger model for specific tasks that can be done by a model that is smaller and cheaper. So for this, we are going to select this, which is going to be faster too. So it's taking the companies one by one, and what it's doing? First is using this browsing tool. It's searching for all the information about the company. Then once it has the information about the company, it goes to LinkedIn and it searches in LinkedIn the people available for that company, all the profiles, and gets the information. And make sure that only fetches the right titles for what I ask. And then once it has these LinkedIn URLs, it will go and use one of the tools that we use for getting the contact information. Okay. As you see, this is all for logging and debugging, but the information is going to be stored here in the output file, which is a CSV that you can easily import from Google Sheets or Excel. Here you have the information with the company, the website, what it does, where's the address, some people, some contacts, and what role in that company they have. If they are someone that is going to is able to take a decision on what you are offering or not, or it's going to be an influencer, or it's going to be someone that can act as support. Okay. An important part, as I told you before, is knowing what is happening and how much this is going to cost. We can see that for this company, for each of these companies, the different tools that we had, how long did it take to use it, and what was the cost. And for this batch of 3 companies, for this session, in almost 90 seconds, we use 4 agents, and we spend this like less than 9 cents to get all that information. Okay, so this was just to show you how easy it is to set up agents, to have them use external tools, and to perform specific actions. Going back to Agent Core, just a quick comment, the availability and limits that it has, that it is in preview right now. This is only available in 4 regions for now, but this is going to grow. And pricing also is probably going to change, and it has like a free trial for these first few months when it is in preview. But yeah, you just have to always check AWS documentation, or just ask us for specific recommendations of cost or availability. Okay, the conclusions were what we saw. These technologies work together to take agents to production. You can use Trans for quick prototypes. You use MCP to connect systems. You can use Agent Core for production. And this is applicable for any repetitive process that can be automated. in this repository, you have this is comes straight from AWS, where you have a bunch of examples that you can apply to your business. And before ending the presentation, I don't know, Will, if we have some questions from the audience.
Yes, we do have a few questions. The first one is when to use AI agents and when bots, for example.
Okay, you use a bot or an RPA when you have a process that is fixed and it is always the same. And you use the agent when you need to think according to every specific case, or you have to combine different sources, or you have to choose between options. So, for example, if you have a process which is resetting a password, you just use a predetermined flow. You don't need any intelligence in that. And if you need to choose the best response to a specific complaint and reviewing different systems, then you can use an agent.
Okay, great. Then how do you avoid wrong inventions or wrong actions?
Okay, I think the meaning the hallucinations, which is a big problem with LLMs, and that is not completely solved. So the answer, what we can do is to connect the agent to only to reliable sources, and you ask it to show the source of what it claims. Or you can put a human confirmation before delivering sensitive actions. You start first in read-only mode and you record everything. You give minimum permissions to each tool. The thing is to be very vigilant on how this agent is behaving, so you can gradually give it more things to do.
Okay, great. And then what's the minimum team and time to go into production with a solution like this?
Okay, it can be one person or more. Well, I like to talk more about roles than the amount of people. You will need someone with a business development or business definition mindset. So someone that can determine what this thing has to do to comply to a specific task. Then you will need a developer to actually build the agent, and you will need someone to deploy it, like a DevOps or cloud person. For just to give you an idea, for a simple case, you can do it in 1 or 2 weeks. But if you have to take into account regulations or many integrations or other thing, you can think about, I don't know, from 3 to 6 weeks. The critical thing here is to have access to the tools and to the data that you need.
Wonderful. And then we have one more question, which
Mhm.
is, what is the best example that you've seen where AI agents are significantly more productive than humans?
Okay, this what we just saw is a pretty good example because it's something that a human can do, but it will take too much time. Basically, it's anything where a human needs to do things online, and these tools are available over the internet, but for the human, it takes too much time. The agent, you can give it access to those same tools, and you can do it faster, or you can do it without time limitation. It can be working 24/7. I don't know, Will, if you have another example or.
Yeah, that sounds pretty accurate, and we actually have seen it working and see that how productivity has improved. Yeah. by a lot for salespeople mostly.
Great.
All right, that's it for the question, Marcel. Thank you.
Okay, great. So thank you for your attention. If you have any questions, just my email is here. I'm available, and here at Silcontech, we can help you with this. Just to start with agents, if you don't have experience, or to guide you for a specific case, how to start implementing them. Okay, thank you so much.
Thank you all.